Hello everyone, I hope that you're enjoying the snow and staying warm. This is section 4.3, right triangle trigonometry. This is used to help us evaluate points on the unit circle that are not necessarily special angles, the 30, 45, 60, and 90 degree angles that we used to find the points on our unit circle. As we talked about, there can be other points on the unit circle besides the points that we actually fill in on the unit circle that we use regularly. And this can be used for that as well. So all of those 30, 60, 90 triangles can also be solved with right triangle trigonometry, because you can use right triangle trigonometry with a 30, 45 degree angle as well. So as far as labeling the triangle goes, the longest side of the triangle is always the hypotenuse, and it's going to be across from the right angle. Across from the given angle, or the angle that you're trying to evaluate the trig function at, is called the opposite side. And then the remaining side is called the adjacent side, and it's the one that's right beside the angle, but not the hypotenuse. So the definitions are given here. Sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Remember, cosecant is the reciprocal of sine, so since sine was opposite over hypotenuse, cosecant is hypotenuse over opposite. Secant is the reciprocal of cosine, so since secant is hypotenuse over adjacent, cosine is adjacent over hypotenuse. And then cotangent is the reciprocal of tangent, so since tangent is opposite over adjacent, cotangent is adjacent over opposite. So in order to remember these first three, you can use SOHCAHTOA. There are other ways to remember it as well, but SOHCAHTOA is probably the most commonly used. If you can remember that, then you would know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then for the remaining three, just like with everything else, for cosecant, secant, and cotangent, we know that those are the reciprocals of these. So we can remember those just by remembering that they are the reciprocals of the ones that we can find from SOHCAHTOA. Here's an example. We're given this triangle with legs 7 and 24 centimeters and a hypotenuse of 25 centimeters. So we're going to start by labeling. So here's our angle. Across from the given angle is the opposite. Across from the right angle is the hypotenuse. And then the remaining angle, or the one beside the angle, is the adjacent. So we've labeled that. And then sine is opposite over hypotenuse. So since our opposite is 7 and our hypotenuse is 25, then sine is 7 over 25. Cosine is adjacent over hypotenuse. So since our adjacent is 24 and our hypotenuse is 25, cosine is 24 over 25. Tangent is opposite over adjacent. So our opposite is 7 over our adjacent is 24. So tangent is 7 over 24. And then remember, cosecant is the reciprocal of sine. So since cosecant, or since sine was opposite over hypotenuse, cosecant is hypotenuse over opposite. Our hypotenuse is 25 over our opposite is 7. And notice that is the reciprocal of sine, 7 over 25. Secant is the reciprocal of cosine, so we should end up with 25 over 24 since cosine is 24 over 25. But just to check, hypotenuse is 25 over the adjacent is 24, and we did. Cotangent is the reciprocal of tangent, so since tangent was 7 over 24, cotangent should end up being 24 over 7. So our adjacent was 24 over our opposite was 7, and we did get 24 over 7. So that's the way we can evaluate trig functions using right triangle trigonometry. In this example, we're given that Our hypotenuse is 4 and one of the legs are 3. That 3 was given in the problem. And so what we need to do is find the length of the missing side so that we have all 3 sides, and then we'll be able to find sine of the angle and cosine of the angle. So our missing side here, we can label x, and then we're going to try to find that missing side. If you've forgotten the Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse. So across from the right angle is our c. The legs are a and b. It doesn't matter which is which for a and b because they're both legs. So our a is 3. We're solving for b. And our c is 4. 3 squared is 9. 4 squared is 16. And then subtracting 9 from both sides, we get x squared is 7. So then we take the square root and we get that x is plus or minus the square root of 7. Well, we know it's got to be just the positive square root of 7 because you can't have a negative length and we're using it to represent the length of a side. So this side is square root of 7. Now we can get to finding sine of the angle and cosine of the angle. So sine, using SOHCAHTOA, we remember that sine is opposite over hypotenuse. And our opposite is across from the given angle. We know that the hypotenuse is across from the right angle, and the remaining side is the adjacent. So our opposite is square root of 7 over our hypotenuse is 4. So sine is square root of 7 over 4. And then we need to find cosine of the angle, which using SOHCAHTOA is adjacent over hypotenuse. Our adjacent is 3 over the hypotenuse is 4, so cosine of that angle is 3/4. So now here we have a right triangle ABC. We know that angle B is the larger acute angle. So we know that one of the acute angles needs to be B. We're told that the legs are 6 centimeters and 3 centimeters. So this leg is 6, this leg is 3. We don't know what the hypotenuse is, so we're going to have to use the Pythagorean theorem to determine the hypotenuse. So our Pythagorean theorem is a squared plus b squared equals c squared. Our legs were a and b, so the 3 and 6 are a and b. And the hypotenuse is what we're solving for, which is c. So 3 squared is 9. 6 squared is 36. And we get that x is the square root of 45. But the square root of 45 can be simplified. So we want to break 45 up into a product of its factors. So we know 45 can divide by 5, giving us 9. So 9 times 5 is 45. 5 is prime, so we can't break that up. But we know that 9 can be divided by 3, leaving 3. So 3 times 3 is 9. So once we have it broken down into all prime numbers, 3 is prime as well, then we're looking for pairs of our prime numbers. So we have a pair of 3s, and then we have a 5 left over. So then, since we have a pair of 3's, what that means is that taking the square root of 3 times 3 would just give you 3 outside of the radical. So everywhere you have a pair, it comes out of the radical, and then whatever you don't have a pair of is left over in the inside. So the square root of 45 is equal to 3 times the square root of 5. So our hypotenuse here is 3 square root of 5. Now that we have all 3 sides, we can find all of the trig functions for that angle. So first we need to determine which angle are we using. It says evaluate the 6 trig functions for angle B. So angle B, I'm going to label with theta because that's the angle that we're using to evaluate the trig functions. Across from the given angle is the opposite. Across from the right angle is the hypotenuse. And the remaining side is the adjacent. So then I'm going to use SOHCAHTOA to find the first 3 trig functions. So sine is opposite over hypotenuse. And our opposite was 6 over the hypotenuse was 3 square root of 5. But then I have a square root in the denominator, so I need to rationalize that. And I can do that by multiplying by square root of 5 over square root of 5. And that gives me 6 square root of 5 over 3 times square root of 5 times square root of 5. Square root of 5 times square root of 5 is 5. 3 times 5 is 15. But then I can reduce 6 over 15. Both of those divide by 3. 6 divided by 3 will give me 2. And I still have the square root of 5 there. And then 15 divided by 3 gives me 5. So sine is 2 square root of 5 over 5. Cosine of the angle is adjacent over hypotenuse. My adjacent is 3 over my hypotenuse is 3 square root of 5. So again, I have the square root in the denominator, so I can multiply by square root of 5 over square root of 5. And that's going to give me 3 square root of 5 over 3 times square root of 5 times square root of 5 is 15. And then I can reduce 3 over 15 because both of those numbers divide by 3. 3 divided by 3 is just 1, so 1 square root of 5 or square root of 5 over 15 divided by 3 is 5. So cosine of the angle is square root of 5 over 5. Then I can find tangent. Tangent is opposite over adjacent. My opposite is 6 over the adjacent is 3. And 6 divided by 3 is 2. So tangent is 2. Now I need to find the other 3, but I know that they're just the reciprocals of sine, cosine, and tangent. So cosecant I know is the reciprocal of sine. So since sine was O over H, cosecant is H over O. My hypotenuse is 3 square root of 5 over my opposite is 6. And then 3 over 6 reduces to 1/2. So that's 1 square root of 5 over 2, or just square root of 5 over 2. Secant is the reciprocal of cosine. So since cosine is A over H, secant is H over A. My hypotenuse is 3 square root of 5 over my adjacent is 3. And then 3 and 3 cancel, and I'm left with just square root of 5. And then cotangent is the reciprocal of tangent. So since tangent is O over A, cotangent is A over O. And then my adjacent is 3 over my opposite is 6, and 3/6 reduces to 1/2.